All right, moving on to 2.4, number 24. 2.4, number 24 says find the asymptotes for cos x divided by x squared plus 2x. Similar to what we've done in the other problems, what I'm going to start by doing is trying to asymptotes are actually fairly easy to find. They're the values that we're not allowing x to be equal to. As our limit approaches these values, we tend to go off towards negative or positive infinity, but we cannot allow it to be that way, or can't allow it to be that value of the asymptote. So one of the things is when you look at a function like cos x divided by, let me see if I can erase that real quick here. There we go. If we look at a function like cos x divided by x squared plus 2x, you ask yourself, is there anything I can't put down here in the denominator? That would be kind of a key that that's probably going to be an asymptote. It's fairly simple to see that I could factor out an x from, there's an x in each term, so this would be x plus 2. If you don't believe me, x times x is x squared plus 2x. What's easy to see in the denominator now is if you let x equal 0, 0 times whatever's in here is going to be a 0 in the denominator. Or if I can get a 0 in the parentheses here, so negative 2 plus 2 would be a 0. So these are my two asymptotes right here. So they're fairly easy to identify. Another part of the problem, though, asks you, it says, take a look at the limit as x approaches a from the positive and the negative, and as x approaches a. So we're going to see where these values are going off to. So one of the things you could do, you could say, well, let me just let this thing approach a from the plus or the minus. So first of all, maybe we let a equal 0. 0 is an easy number to deal with. Well, unfortunately, we can't do f of 0. F of 0 is not allowed, right? Cos of 0 works out fine. But what happens down in the denominator is you get a 0. So you can't do that. But let's say we wanted to approach 0 from the positive. So let's do a limit as x approaches 0 from the positive of the cosine of x over x x times x plus 2. Get that erased here real quick. X times x plus 2. Alright. Alright. So one of the things you might say is well, I could do like f of 0.1. That's to the positive side of 0. And that would be equal to cos of 0.1 divided by 0.1 times 2.1. If I add 0.1 to that. And then I could say, well, let me get closer yet. What's f of 0.01? Well, that'd be cos of 0.01 divided by 0.01 times 2.01. And so maybe we'll actually try that real quick. We'll hit escape here, keep my annotations. I'm going to go down to my my calculator here real quick, and let's just select something here, and let's say we'll do the one down the bottom here first. The cosine of 0.1. So 0.1. We'll take the cosine of that, we get that number, and we'll divide that by 0.1 times 2.1, and we get a number like that. We get 4.73. So I could say, okay, this goes off to this is equal to 4.73. Okay. Well, then what happens if I go a little bit larger than that, right? So we'll keep our annotations here. We'll go back into our calculator, and this time we'll do 0.01 cosine, and we'll divide that by 2.01 times 0.01, and that's going to equal that. And I think what you'll see as we go through this is it's getting bigger and bigger and bigger. Now we're up to like 49.7. And I'd venture to say if you did f of 0.001, it would go up to maybe 497, and it's going to get bigger and bigger and bigger. So what you can say about the limit as this approaches 0 from the positive is that it approaches positive infinity. All right. So something interesting to say as well. I know somewhere in this graph, as I approach 0 from the positive, so I'm going in this direction, my graph is going to go up like this, up towards positive infinity. So let's take a look at this and just see if we're even in the right ballpark here. So let me go in. I actually did this in Desmos here, and you can actually see crystal clear that you have a let me see if I can grab this real quick. Maybe I'll just take a screenshot of this real quick here. Where's my snipping tool? There it is. Boom, there we go. Copy. Go back into PowerPoint for one moment. New slide, and we'll paste this in there. So what you can see when you look at this is you can actually see you have your asymptote at -2, like we just talked about. You have your other asymptote at 0. And like we just proved a minute ago, is as I approach 0, the limit as x approaches 0 from the positive of f of x equals positive infinity. Now we didn't do the calculation for as it approaches from the negative, but we can see that here too. The limit as x approaches 0 from the negative of f of x equals negative infinity. Well, then we could do another one too. We got -2 over here that we'd worry about a little bit. So we might say the limit as x approaches -2 from the positive of f of x. So -2 from the positive. So that's I'm going from the right. So I'm approaching -2 from the positive. I'm heading this way. It's going to positive infinity. And then the limit as x approaches -2 from the negative, or from the left of f of x, equals, and now this, we're following this line, so we're approaching -2 from the negative. It goes off to negative infinity. So we can see these are not dual-sided. They go off to opposite directions. But the big thing here to notice is where your asymptotes are. -2 is one of your asymptotes, and we actually diverge to negative infinity or positive infinity, and 0 is an asymptote also, and we diverge to negative infinity here or positive infinity here. So that would complete 2.4, number 24.